Hey guys, Mr. T here. This is another video on simultaneous linear equations. So linear equations are equations in the form y is equal to mx plus c. And linear equations that involve the same variables, so a pair of linear equations that involve the same variables but have different relationships represented by those equations, they can actually be solved at the same time. Thus, simultaneous linear equations. The solution finds a value for both of those variables that satisfies both of the equations. So, for example, let's say our two variables are x, which represents the number of bicycles, and y represents the number of tricycles. Bicycles have 2 wheels, and tricycles have 3 wheels. There's a relationship between the number of bicycles and the number of wheels. The number of wheels from bicycles is going to be 2 times by x, because that's the number of bicycles. The number of wheels coming from tricycles is going to be y times by 3. There's another bit of information that we know to form a relationship, because there are 13 bicycles, and another bit of information is that we know that there are 31 wheels in total. Having all of this information, these two variables, lets us form two separate relationships, two separate equations that use the same variables y and x. We can extract these two relationships using those variables, because we can say the number of bicycles. That's something I know. We know there's 13, not bicycles. We know the number of cycles is 13. Now, because x represents the number of bicycles and y represents the number of tricycles, we know that the number of bicycles add the number of tricycles is going to be 13, because we've been told the information that there's 13 just cycles in general. The other bit of information we know is that there's 31 wheels. So we can form a relationship that involves the number of wheels total and those two variables x and y. We just discussed before that the number of wheels from bicycles is going to be 2 times by the number of bicycles there are, because each bicycle has 2 wheels, 2 times by however many there are. And then the total number of wheels from tricycles is going to be 3 times by however many tricycles there are, so 3 times by y. And because we know there's 31 wheels in total, well, the sum of number of wheels from bicycles and the number of wheels on tricycles should add up to 31. So you can see here there's two separate relationships, and they both involve the variables x and y, which represent the number of bicycles and the number of tricycles. Now you could solve this by trial and error. Yeah, you could go, okay, let's say if there was 1 bicycle and 1 tricycle, well, that would only equal 2 cycles in total. That wouldn't satisfy the first equation, and it certainly wouldn't satisfy the second equation, because 2 times by 1 is 2, 3 times by 1 is 3. That wouldn't add up to 31, that would add up to 5. You could trial and error this and just keep going up the numbers until you find the right combination, but what you'd find if you spent the time to do that is that the number of bicycles would have to be 8, and the number of tricycles would have to be 5. Let's check if that satisfies it. Well, x is 8, y is 5, 8 plus 5 is 13. Well, that satisfies the number of cycles in general. Does it satisfy the number of wheels? Well, 2 times by 8 is 16, and 3 times by 5 is 15. 16 plus 15 does indeed make 31. So this solution of x is equal to 8 and y is equal to 5 satisfies both equations at the same time. It must be the solution to these simultaneous equations. So we need to go over different ways of solving what's known as simultaneous linear equations. And we've got 3 ways to do that, because obviously you can't do trial and error. You don't have the time to do that and try all different combinations. You need a more direct method of solving and finding the solution for both equations. You have 3 of those. You can do it graphically by graphing the 2 separate lines and finding where they cross over. You can solve it by substitution, and that involves substituting one of the variables if you've rearranged it to be the subject of a formula, and substituting that variable into the other equation And then the last method of solving simultaneous linear equations is by elimination. And you do this by eliminating one of the variables using an opposite signed coefficient. And that'll be made clearer in the video specific to that. So hopefully that's a little introduction to the idea of simultaneous linear equations. They're just two separate linear equations that both involve the same variables. You can solve them at the same time with one solution. I'll see you in the next video.